Given the table comparing shielding, effective nuclear charge, and atomic radius of these two mystery elements, where is element 2 in the periodic table relative to element 1? Is it up and to the left, up and to the right, down and left? Let's look at the factor of shielding first. Now the table tells us that element 1's shielding is bigger than that of element 2, but we must first understand what shielding is to discern the relative position of these elements on the periodic table. Shielding is the phenomenon where, by nature of their proximity to the nucleus, inner core electrons block the access of our outer electrons, our valence electrons, from forming an attraction with the nucleus. Adding to this effect, inner core electrons also repel our valence electrons, as like charges repel, further depriving these outermost electrons access to the nucleus. As a result, the atom's radius increases because the force of attraction between nucleus and valence electrons is weakened. It's smaller. Looking at the periodic table, as we go down a group, we add shells of electrons each time. Hydrogen has 1 shell, lithium has 2 shells, sodium 3, and so on. We keep adding electron shells as we descend down the periodic table. Unsurprisingly, the more rings of electrons we have, the more shielding that occurs, simply because there's more layers of electrons within to block the outermost shell from connecting with and forming a strong attraction with the nucleus. So more broadly speaking, shielding is low at the top and high at the bottom of the periodic table because of low numbers of shells and high numbers of shells respectively. Therefore, because element 2 has less shielding than element 1, element 2 will have less number of shells than element 1, so it's going to be above element 1 on the periodic table. Say, for example, that we have arsenic as element 1, element 2 is going to be above that. Thus, we can eliminate choices C and D because element 2 is going to be above element 1 on the periodic table. Now let's look at effective nuclear charge. E and C is a horizontally related factor, and we'll examine period 2 to really see how this plays out. So all of the elements in row 2, or period 2, have 2 shells of electrons, and each atom within the period has the same number of electrons and protons respectively. 3 and 3, 4 and 4, 5 and 5, all the way to 9 and 9. So even though we have the same ratio of electrons to protons all throughout the period, the nucleus is 3 times as positive, whereas each additional electron that's being added is to the same outer second shell. This means that fluorine's nucleus is going to be better, stronger in attracting its valence electrons closer to itself, and we call this phenomenon effective nuclear charge. F has high effective nuclear charge, Li has low effective nuclear charge. So, effective nuclear charge increases as we go from left to right. So if 2 has bigger effective nuclear charge, it's going to be to the right of element 1. So if we put both factors together, the fact that 1 has bigger shielding, 2 has bigger E and C, we can see that element 2 must be over here in relation to element 1. Or if we had element 1 as Sn, it would be over here. Regardless, element 2 is going to be up and to the right relative to element 1 on the periodic table. And this makes perfect sense with atomic radius comparison, because if something is up and to the right of another thing, it's going to be smaller in atomic radius relative to 1. And that coincides with atomic radius trends, because whichever element of the two has greater shielding, in this case element 1, is probably going to have a bigger radius.